Okay, I'm going to do the performance assessment review guide. I will be succinct as possible because Haley Reyes says I talk too much. But I have to talk the amount I have to talk, and I will try and keep everything in focus and everything in the camera. So, first question. 100 milliliters of water is placed into a 200 milliliter graduated cylinder. A Lego character that has a mass of 23 grams is placed into the graduated cylinder so that the water level is above the level of the character. That's called water displacement. Basically, you're just measuring something, the volume of it. Like if I wanted to know the volume of something that I couldn't just measure the shape of, like this, for instance. There's a way to do that using water displacement. You put a fixed amount of water, say 100 milliliters, into a graduated cylinder. And then I put the Batman character. For me, it's Batman. You can use whatever character you want. I put the Batman character in. And the water level goes up to 118 milliliters. What is the density of the character? In complete sentences, write the procedure for finding the density of the Lego character. Okay, so I would first find the volume of the character through water displacement. By placing the character. Do I need to change this? I need to like slide this in a little bit, don't I? That will steady it up. Placing the character in a graduated cylinder. With enough water to cover the character. I would subtract the initial volume of water from the final volume. Basically what I'm saying is that I would have 100 milliliters of water, and then after I drop the character in, I would have 118. If I subtract 100 from 118 from the final volume, from the final volume, I would subtract the initial volume of water from the final volume, which would give me the volume of the character. I would then mass the character. I would finally divide the mass by the volume to obtain the density. And then I'm going to put the problem here. So I have this equals, because density equals mass over volume. Mass over volume. So I have whatever equals 23 grams over 18 milliliters. And, need a calculator. 18 divided by 23 equals 0.782 grams per milliliter. 0.782 grams per milliliter. As a sideline, would this character sink or swim? He would swim, because anything less than 1 gram per milliliter means that he would swim. Remember, water has a density of 1 gram per milliliter. Okay, so that was the voluminous one. I would first find the volume of the character through water displacement by placing the character in a graduated cylinder with enough water to cover the character. I would subtract the initial volume of water from the final volume, which you could have put, I would record the volume of water I put in the graduated cylinder before I stuck in the character, but that's implied here. When then mass the character, I would finally divide the mass by the volume to obtain the density, and we did just that. Okay. Based on the chart below, if a sample of metal has a mass of 420 grams and a volume of 40 milliliters, which metal below is the most likely metal? Okay, so we have 420 grams divided by 40 milliliters equals 10.5. If we look at our chart, oh, I think we have a winner. It's silver. The big takeaway here is density equals mass over volume. I hate this triangle, but if it helps you, then God love us all, use it. Later, when you get into physics, you won't be able to use that, by the way. All right, so let's continue on. Oh, I need a periodic table too. There's one. Okay, periodic table. The atomic number of sulfur. Well, that's pretty easy. It's 16. The atomic mass, I was getting ahead of myself, is 32.1. Atomic mass is right here. Number of protons, A equals P equals E. So 16. 16. Atomic number equals number of protons equals number of electrons. Unless they tell you something different, this always holds true. Now, in order to find the number of neutrons, I take the atomic mass, I round it, so I'm going to make it 32. I subtract the number of protons, minus 16 equals 16. That is my number of neutrons. And this is an element. All right, number of protons, 35. Well, we know that the number of protons is equal to the atomic number, so bromine is what I'm looking at. So let's do bromine. And we know that its atomic number 35, and we know that its atomic mass is 79.9. And that if I round that to 80 and subtract 35 from it, I get 45 neutrons. And they've changed the number of electrons here. So this really is Br minus. This really is this, because they've added an electron. So I have one more electron than I have protons. And if you have one more negative charge, then that makes this charge -1, hence the little negative symbol. And it is an ion. If I change the number of electrons from what it has in its stock configuration, and in its normal neutral configuration, it has 35 electrons. Well, this has 36, so therefore it is an ion. All right, 63.546. So all I have is an atomic mass to go by here. 63.546, so I'm going to say that's copper. I'm going to say that its atomic number is 29. I'm going to say that it has 29 protons. 29, copper. 29 protons, 29 electrons. A equals P equals E. And the number of neutrons, if I round this, it rounds to 64. 64 minus 29 is 35. 35 neutrons, and this is an element. Ooh, my OCD is flaming. Uppercase, lowercase. Okay. The last one, number of protons, 15. So 15, this is phosphorus. it has an atomic mass of 31.0, and its atomic number is 15. It has 15 protons and 15 electrons, and it is an element. Oh, wait. But wait, is it an element? So how do we know? Well, if I round this to 31 and I subtract the number of protons, I would have 16 neutrons, but they've indicated something different here. So by indicating something different, and the different number of neutrons, I know that this is an isotope. Remember, the only thing that changes in isotopes is the number of neutrons. The only thing that changes in ions is the number of electrons. And you never change the number of protons. If you change the number of protons, if I go from 16 to 17, we have a completely different element. It is now chlorine. Okay. All right, I'm going to stop the video and restart so that these are little chunks instead of big chunks so you can find the chunk you want.